Have you ever wondered how sound travels? Join me in this video to know more about sound. Sound. It's almost impossible to imagine a world without it. It's probably the first thing you experience when you wake up in the morning, when you hear birds chirping, or your alarm clock bleeping away. Let us give meaning to the word sound. Sound is defined as vibrations that travel through the air or another medium as an audible mechanical wave. It is produced from a vibrating body. Let's say you're relaxing and listening music through a music system. The question what we're looking is, how does sound travel from the speaker to ear? Sound is a form of energy that needs a material to travel. What do you think is that material in this case? The material is air. Sound is traveling as a wave or a disturbance of the air particle. Now, what do we mean by the term wave? Since the air particles are invisible, let's take the example of water. In this experiment, we will be needing a basin, pieces of stone, can either be small or big, water. First step is we will fill the basin with water. Wait for it to stay still and hold your stone ready to throw it on the water. Let's try it again using a small piece of stone. We can notice that when we drop the pebble on the basin, we saw a wave or ripples on the surface of the water. Similarly, sound is traveling as a disturbance of the air particles. When the speaker is playing, the speaker is vibrating. Sound is produced by vibrations. To understand how the sound travels through air, illustrated is a picture of a speaker and the layers of air. Each layer of air is made up of tiny air particles. So you can imagine this series or layers of air between the speaker and yourself. When the music is off, these layers are stationary, which means that they are not moving. Now imagine that the music is on. Vibrations are coming out of the speaker, and these vibrations disturbs the layer of air. The vibration will go ahead and disturb the first layer of air, which goes ahead and disturbs the second layer of the air, and this disturbance will continue to the rest of layers of air. If you consider the first layer of air, let it go ahead and push the second layer of air. But because air is an elastic medium, which means it has some elasticity, it behaves like a rubber band. So the first layer, after disturbing the second layer, will go ahead and springs back to its original position. Similarly, the second layer of air, after disturbing the third layer of air, will spring back to its original position and do the elasticity of air. This process continues. If you look at the final layer of air, they will push each other, and then the last layer of air goes ahead and hit the ear. The disturbance goes and vibrates the eardrum in the ear, which causes the sensation of listening or hearing. Sound is traveling as a disturbance of air particles. That's how we can listen to the music play. As the music keeps playing, the vibration are coming out of the speaker continuously. This causes a continuous movement or disturbance on the air pattern between the speaker and the listener. Let's imagine that we are on the moon and we are having a conversation. When we're back to the earth, you are so confused because you cannot hear anything on the moon. Why is that? Because there is no air on the moon, and sound needs air to travel. In this experiment, we will need materials that can easily be found inside our house. First, you will need a bowl, grains of rice, cling film or plastic wrap, which we use to seal our foods. We will also be needing scissors and a speaker. You can also use your cell phones if you don't have speakers at home. What we're gonna do is we will get a piece of cling film and attach it on top of our bowl. We will make sure that nothing will pass through our bowl, so we will seal it carefully. That will serve as our base for this experiment. Next is we will put the grains of rice on top of our film, and you'll notice a vibrating sound caused by the rice. Now let's turn on our speaker and do the experiment. We can notice how sound waves or vibrations in the air causes particles to hit each other. Here's the deal. Solid, liquid, and gas are three-dimensional. That means sound waves themselves are three-dimensional. Solid. Sound travels fastest through solids. This is because molecules in a solid are packed against each other. When a vibration begins, the molecules of a solid immediately collide and the compression wave travels rapidly. Between liquid and gas, sound travels faster in liquids than in gases because molecules are packed more closely together. So we can conclude that sound travels faster in solids than in liquids and faster in liquids than in gases. A firework goes off, the sound travels outward in all directions. You'll hear it whether you're north, east, south, or west of the explosion. You'll even hear it flying above in an airplane. As the sound energy travels outward in those three dimensions, it quickly becomes less concentrated. The further away, the less sound. So, the further away you are, the longer it takes for the sound to reach you. And that's the end of our discussion. See you next time!